In this video, I want to talk about my latest project, app architecture with reliability in mind, from Kubernetes to serverless with GCP Cloud Build and Cloud Run. It consists of a blog post and a Git repo created with all reference deployment code I used in later steps. As the title hints, as part of this video, I'll cover how and why I decided to use a serverless service. Cloud Run, in this case, is a failover option for one of my apps that's running on my private Kubernetes cluster, and why I might even migrate some of these workloads completely from Kubernetes to Cloud Run. So in this blog post and video, I'll cover two ways how to deploy an app hosted in GitHub repository to Cloud Run. So there, as mentioned, two ways. So first, I'll show how to deploy app hosted in GitHub to Cloud Run automatically using Cloud Build, which you can think of as a CI/CD configuration file for automated Cloud Run builds and deployments. And in second step, I'll do the same thing as in the first step, but this time, all the resources in GCP will be automatically provisioned and set up using infrastructure as code tool Terraform. And as part of this step, I'll even do a live migration of my app from Kubernetes to Cloud Run and Cloud Build. And please note, as part of this video, I'll add timestamps for each section so you can skip between different parts covering here. And all relevant information will be available in video description. So let's get started. So the blog post you're reading is hosted on a private Kubernetes cluster that runs inside of my home. I wrote about this a while ago, but it's very extensively written. If you're ever thinking of doing your own Kubernetes, private Kubernetes setup, which software I chose, which hardware, which UPS, everything. I explained absolutely everything, and I've been running my workloads, private and public workloads, on it for some time now. So another workload that's running on the same cluster is atuf.app, which is an acronym for Amsterdam Toolkit and Urinal Finder. It's a web app which I created to help keep Amsterdam streets clean by helping folks find a nearby toilet and urinal. So this is what it looks like, the web interface. So it consists of, you see a map of Amsterdam, and you have different markers. So green ones are the centuries-old P-curl urinals, for example. You also have different symbols, so you know that you can do your thing sitting also. So this is a public toilet. In this case, there might be free and paid. Orange ones are retractable urinals, so their opening hours might differ because they might go underground. Some of them might be part of the parking garage, or they might be seasonal, and so on. And you can even track your location, which is not as accurate on the web UI, but it's very accurate on your smartphone. So you can see your location, and you can see, like, okay, this is the closest toilet or urinal that I need to use. Why and how I came to this idea is a long story, but it's literally something that was chasing me for years. And I described it as part of my blog post, and how the only time I found to do this was like doing my paternity leave in a half-awake state after the birth of my second child. But you can read more about that later. So since its release, atuf.app was featured on popular websites like Dutch News, which is a news site in English for everything that's happening in Netherlands. So I was actually featured here as part of the technology segment. And my name is mentioned, atuf is mentioned, of course, And since this happened, the availability and uptime of atuf app in this blog, basically, a few other private workloads, became even more crucial. So I've been thinking how to improve the reliability of these services for some time now. So getting to what is the problem of running apps on private Kubernetes cluster? So I created my private cloud and Kubernetes cluster with reliability in mind. So it's running on 3 Raspberry Pi nodes, and even if one of them dies, it will continue running as if nothing happened. And even if all 3 nodes went out, I created a RPA MicroK Bootstrap project, which can be used for automated provisioning and setup of Ubuntu server and MicroK on a Raspberry Pi using Terraform. So it will allow me to recreate and recover my cluster in a matter of minutes in case something goes wrong. Data is stored on Synology NAS DS920 with 32 terabytes of storage with Synology Hybrid RAID and Btrfs. And in this setup, even if one of the disks fails, it will continue running as nothing happened as for disk array. Same thing is, it's also everything is backed up to another Synology NAS with another 4 disks and another where disk can fail with 1 disk redundancy. Even in the case of complete power outage at my home, UPS unit will kick in and the cluster will keep it running for a while. I have monitoring and I get alerted on both SMS and email in case my sites go down. So this is what it looks like. It's also on the blog post. But even with all of this, with all of these actions taken, accidents still happen and are great ways when you're in, because something it really takes a while to fix it. So, which is especially a problem if you're not home and you don't have a laptop nearby. So, SSHing to your cluster from your phone and to debug your app is not a fun experience. And especially if you're at work with your kids and you're unable to do this, because it's more important to take care of your kids than your private Kubernetes cluster and its workloads. So I've been thinking a lot what would be the ideal failover or disaster recovery solution that would allow me to recover with minimal time and effort, and maybe even completely move to it. And the solution checked all the criteria, which is Cloud Run. So for those who do not know Cloud Run, Cloud Build, Cloud Run is an execution environment based on Knative. So it's a serverless platform offered by GCP, Google Cloud Platform. It's managed by them, and one cool thing about it is that it does not incur any costs. So if the workloads are in idle states, there is no incoming traffic, and you're not gonna incur any costs. You're completely fine. Also, it allows you to scale automatically to meet the demand of about incoming traffic or other metrics, which is perfect use case for my workloads, which are utilizing HPA, horizontal pod autoscaler, for example. Cloud Build, on the other hand, is a serverless CI/CD service on GCP, which allows automated building, testing, and deployment of containerized apps. And something I couldn't pass on, because considering how seamless of an experience is to build code with Cloud Build and then automatically deploy to Cloud Run. So, since I couldn't find any of these exact workloads anywhere on the internet, that's the reason why I decided to create this blog post and video, hoping it could serve as an ultimate guide if someone trying to do this thing, which is connecting your app to GitHub or anywhere else with Cloud Build and Cloud Run. So those who don't watch this video or anything, I created a repository with all of the reference code that I'll be using, so you can take a look into that. And if you need any help setting this up from Dockerfile to Cloud Build, Terraform code, it's all there. Regarding app architecture, it's a Python Flask app. It's picking up all of the data. It's scraping all of the data from apps.amsterdam.nl, where it's publicly available, and then saving the coordinates in JSON file. Then the data will be processed, manipulated, made be removed, added, and then Folium Python library will be started to create the map and place the markers. And then the UI changes will be made, and the map will be served. And there's that Docker file, which again is also in the repo, which creates the containerized application in the container as a container. So please note these steps, they all have different requirements, and some of them might be very long, especially for the Terraform part, because Terraform is all about automation. But everything that you need to do you will only need to do for the first time. I also encourage you to watch both things, because maybe I'll focus more on explaining cloudbuild.yaml in the first step, but will not go into it at all doing the second step. With that said, let's just get started. So for the first step, I have a list of requirements. So GCP project, I have it. Containerized app, I also have the reference code, and I need to enable the following APIs, which I open here. So just enable them one by one. Now that they're enabling, I'll give it a second or two. One important thing is what you'll need to do is increase cloud API limits. For example, if you don't do this in the Europe West 4 region, I would run into this error. So what I would advise you is to go as part of a IAM, quote, and basically you'll need to filter it on Cloud Build API. So Cloud Build API and concurrent build CPUs. And I already did this for my region, West 4. I increased them to 20. But please make sure that this is done. I added, for example, sample screenshots, how to do this, and even how to do the sample request. But it's important to do this because after you do this, you will get an email from Google support, and this process might take 2 days. For me, this process took less than a day in every case that it happened, but please be aware as it could take longer than, so it could just leave you in block state. Talking about this, we also need a service account. I'm not going to get into why is it good practice to create service accounts. You should do your own research, but we will use and create a new service account for our purpose. And in this case, this is Cloud SA. I created it. As part of the IAM part, I attached following roles to it when I created the service account. So you can also see it here. I think this is very simple stuff, so I'm not going to do this on video. But there's an explanation why each role is needed and so on. And once all of this is ready, you will want to create artifacts registry. And so I'm going to create registry. I'll call it atuf Docker. It's going to be a Docker repo, and I'll just select it to be in Europe West 4 because I live in Amsterdam. This region is the closest proximity to where I live. And I'll leave everything as default. Just I'll actually do this. I'll create cleanup policies later on with code. So I'll just create the repository. And once the repository is created, that's basically it. So we have all of the requirements ready. So what we need to do now is we need to go first show how simple of a process this would be if you just wanted to do it with Cloud Run. So this is how Cloud Run looks like, and I would just go create a service. And for example, you could simply just add an image URL right could be from Docker Hub or GCP artifacts registry. You would add a name, atuf, for example, select the region, allow unauthenticate in invocations. So this is for public facing websites. Well, not good, but you get the point. But even then, I would recommend that, for example, you enable a CAPTCHA as part of your app, or do some kind of rate limiting. As if someone DDoSed this URL, you would get a very high bill at the end of the month. So, but basically, this is how simple it is, and you would only need to make sure that you're running as part of this port number, and that's about it. You would click create, and that's it. But what I want to do in this case is I want to use cloud build. So cloud build will allow me to automatically build some things. This is my dashboard. I think is going to show, an existing trigger. So I'll recreate it, and you will also need to connect a repository. I actually covered this as part of the second step, step 6, how to manually, for the first time you'll need to do this, so please keep this in mind. So now I'm just going to create a trigger, and I'll call it atuf trigger because that's the same name for the other one we created with Terraform. And I'll leave everything as it is here. So now I already authenticated with my repository, so I'm going to select it. So whatever happens on the main branch is what's going to trigger the whole build, and that's what I want. Type. So this is the important part. For beginning, if you're just getting started, you don't have a cloud build, although you can use the one I created in the reference repository. You could use Docker file. But the problem with this and problem with Cloud Run is, like for every new build, you will need to create a new image of container image on your own, and then you deploy it. And what I want to here is automatically container images to be created with each push to my main branch. So I will select Cloud Build configuration file in this case, and I'll select the Cloud SA service account that I created for this purpose, and that's it. I'll click create, and there it is. That's the Cloud trigger, and I will now click run main branch, and off it goes. So. These are the older runs, so you can forget about them. But this is what one such run looks like. So it has steps that it's doing. Now it's pulling the image. It's actually cloning the repository. Regardless, all of the steps are defined as part of Cloud Build. So this is what's happening now, and this is also in the reference repo that I created. So it's going to use only cloud logging. That's what this option is for. It's going to set up some environment variables. So for example, I can use project everywhere instead of, that I can reuse it instead of having to specify it manually each time. Then it's going to build a container image. It's literally doing Docker build T, then the location where the container, the name of the container actually, then it's going to authenticate with the GCP artifacts registry, and then it's going to push the container image to GCP artifacts, and then it's going to deploy the container image to the Cloud Run. So it's literally doing Cloud Run, deploy, name, atuf, region, memory size, number of instances, maximum number of instances, and which class service account to use. So that's why I created this one. And this is the option I was talking about, where it's going to allow unauthenticated access to the app. So this is happening. We can give it a little bit of time because for the previous run, it usually finishes in like 3 minutes for me. So I'll give it a couple of more minutes. I'll actually pause the video. So while this is still happening, I want to show how by now the app has been, the container has been pushed to the artifacts registry. So I want to show what it looks like. So yeah, here we go. Again, this is all being done as part of the cloud.build.yaml, and there's our image just now. It showed up there. Just so you know, this is the path that it goes to when you're deploying. If you need a path, this is what it looks like. So keep that in mind. And I'll refresh. I believe now that it has finished. Okay, not yet. And please note, during the initial run, the logs will not be as verbose. But once you push the changes, for example, with next run, there are going to be a lot more verbose, and you can see what's happening. But we also need to see, we'll need to wait until it's completed first, of course. So I'll pause the video. This is going for a while, actually. And just as I paused the video, it completed. So there's our build, successful build. So if we go to the dashboard, we can see it. But that's all great. But where's our app? So that's where we go to Cloud Run now. And in Cloud Run, we should see running service, which we're not seeing for some reason. Oh, there it is. So allow unauthenticated, deployed with this service account, and yeah, there are the metrics, and there's the randomly generated that you get. So, for example, there's the app, and I'm gonna refresh it a couple of times just to generate a few some metrics. So let's refresh this page. And yeah, on metrics page, now we should see some request counts. Yeah, for some, the console is taking its time today. And yeah, you see the requests coming in, a couple of other things. That's all great. You can also define your SLOs, which in this case I have not done. Logs, you should now see the browser coming in. Yeah, so you can see the browser here making the requests, what's happening. You can further extend this. Revisions. So one thing that's cool about this is I didn't like you cannot see it because of my face, but there's a window here and it says atuf.app and like a shrug face, which is not how it looks like on prod version on Kubernetes cluster, because this is what it looks like. It says Amsterdam tool and Urinal finder. So we have a bug here. So what I'm going to do here now is I'm going to go to the actually the problem is here. Okay, cool. So I'm going to fix it. And while I'm at it, so besides making the UI changes, I'm also going to actually upgrade to a newer version of Python. So fix UI and upgrade container image, and I'll commit these changes, and the changes have been pushed. So if I go back to cloud build, which I shouldn't have closed, but I did it anyways. So cloud build, now we should see automatically that there's a new build, and see, because the changes were pushed and immediately it triggered a new build. So 20 seconds that I pushed the changes. So what's cool about revisions is that basically you can manage traffic. So for example, you can maybe send 50% of traffic to a new release and 50% to the old release. So if something breaks, that not everyone sees the breaking changes. That's a very useful feature to have that just something to keep in mind. These are the networking options. For now, it's all, it's set to all. Security, same thing. There's no triggers and integrations right now. But regarding what I was talking about, this being Knative, this you even see the whole YAML if you wanted to migrate this anywhere else, and it looks very Kubernetes like. But that's what it is there. So I will actually pause the video again just to show. I'll wait until the changes are there. While I'm waiting for this to build, I can show a little bit more in detail of what's happening as part of each step. What I was saying before, how you need to wait for it to complete to see it in a proper or in full detail actually. So I'm now looking at what it looks like for the previous build and push. This is the push, and then the cloud run. And another thing, let's see first if this is completed. Okay, so it's still running. Another thing that I wanted to show here as part of it is that you have an option to add manage custom domains. So now you have that randomly generated URL, which is not easy to remember, of course. So what you could do is you could just add your own domain name, and that's what I will actually do, but in the next step, because now we'll be clicking around and I don't want to be doing any clicking. So this is completed now. So we have another successful build. That's great. So if we open the app again, and now the UI problem has been fixed. So it's that easy to push new changes, and again you can split the traffic. So that's very nice, and it's running on the latest updated container version. So now that I covered this, I want to move on to doing this, which is do the automatically deploy app changes that's hosted in GitHub to Cloud Run using cloudbuild.yaml and avoid any ClickUps with Terraform. So let's see what that will look like. So here we have again a list of requirements. So GCP project, I have it. I have the containerized app. This can be cloned. This is also done, and now there's you still need to enable two API and services. So just FYI, this is needed because at least the first one is needed, for example, for this module to work. It's requirements. As you can see, the other APIs will be enabled with, but enable them manually. So they're already enabled. So with that said, let's continue. The fifth step is you still need to increase the quotas, which I described as part of the previous step, so I'm not going to get into this. And another reason why this is happening is because the Google Cloud Build Trigger Terraform resource does it, while it has an option, which I'm using actually here, to create the Cloud Build Trigger, it does not have the option to have it automatically triggered. So that's why I actually resorted to some hacks, how to enable it manually with, not manually, but in automated fashion with gcloud command, for example, and then some clever engineering, because once you trigger it, because like this Terraform code would be deploying the trigger, and then you would have to go manually and click run, which I don't think is that's not good. So then the gcloud command will trigger it, and then while you're waiting, basically I created a polling mechanism that allows has a script which which I can also see here, which is waiting and doing checkups if the Cloud Run service is ready, and it will do this for 30 attempts. So basically, again, it's going to be a gcloud command, just checking if the what kind of status is the gcloud service running. And what else? So besides that, sixth step is the connection to gcloud will have to be also manually done. But this is only the first time you need to do this. But it's still, yeah, it will need to be done. And if you're doing this for the first time, then you'll also need to have an additional build API enabled, which would be otherwise enabled automatically with Terraform. So just keep this in mind if your build fails. And unfortunately, this also will never be done automatically, as it's also explained in this bug that was closed like 3 years ago. So that's also not ideal, but that's what it is. So then the seventh step will be to create a TF deploy account, service account, with following roles. This could also be weeded through, and they could be less permissive, but these are the roles I went with. So once the account is created, so if I go to IAM, I'm not going to do this. I think this is very simple to do, and something that you can do on your own. But I'm actually now in the wrong project. So service account. So this is our TF deploy account, and it has a key attached to it. And then this key will also need to be downloaded. So I downloaded and I saved it to .credentials tf deploy.json file. So this is again something that you can do on your own. And once that's also done for that same for this Terraform module to work, I'll need to export this environment variable, and I can show you what it looks like. So I'm using Z shell here, but you can use bash or whatever shell of your choice. And this is what it looks like. And then you just export it as I showed here. And after that, you need to also authenticate the TF deploy service account with gcloud. So for that polling mechanism that I was referring to before to work. And you can just copy paste, of course, adjust this to what you have on your system, and you can verify that if it was done properly. Since I did this, I can just do a verify command. And that's the service account. And optional step, the step I was talking about, how to add custom domain names. So basically, the full TF deploy service, in this case, this account, this whole domain name, email has to be added as part of your Google Search Console. You need to add it as an owner in this case. So I'll show what that looks like. So I'm going to go to settings. Users and permissions, and that's where I added as an owner, because otherwise Terraform will not be able to do this. If you're not using Terraform, you just need to point it, you're just using the web UI, you just need to have the principal email that's used in this case. In my case, is the same service account, but it might be different for your use case. So once all of that is done, so the reference repository is there, I can just start. I can do the Terraform init plan and apply. So, since I did a Terraform in it and I did everything, I can look at a plan, what it looks like. Terraform plan, what it would want me to do. And of course, I'm not in the right directory. Okay, so yeah, it will create what I wanted to create. Okay, so it looks all right. So I'll have confidence that this will work as it should. So I'll just run this command. So it's not going to prompt me for anything. It will just go and do its thing. And while it's running, I'll actually walk you through the code that's executing right now. So, as I might have mentioned, there are providers set up, which providers I'm using, the credentials which it's using, so that's that .credentials tf-deploy.json file. That's the project services Terraform module, which is enabling the APIs. This line will actually disable all of the APIs once you do Terraform destroy. I like infrastructure as code principles, so it's like doing it for the first time every time, but this might be different for your use case, so you might want to set it to false. This is going to create the cloud SA, so the service accounts we created manually in the previous step now is going to be created automatically and with list of rules that it needs in order to run successfully. And then these rules will just be applied to it. And it's also going to create that atuf repository that we previously created manually, and it will even add the cleanup policy to keep only the last three versions. And after that, it's going to create the cloud build trigger. And after the trigger is created, that's that part I was mentioning in step one of the steps where you will need to authenticate before only the first time, and it's going to trigger the trigger. So it's going to use cloud build to trigger it. Otherwise, I would have to go manually. I can even show you what this looks like right now. So cloud build, because this is already happening. And so the trigger would be created or is already created with Terraform, and again it's using cloudbuild.yaml, and it would need to run, and now it's running, so it's already running as we can see here. And now it's doing the polling mechanism. So this is what you see here. It's getting errors because it's basically poking it, checking like, hey, are you ready? So this is where that script is running, and it's checking if the atuf cloud run is there yet, and if it's a successful state running as it should. So we can wait. Usually it finishes around 15th attempt. I can even go to while we're at it. Cloud run. Cloud run. Okay, it's not ready yet. Okay, 11th attempt. Should be done soon. So now, just for understanding, the Terraform did the same thing with the first step with the cloud build, and the cloud build triggered the image creation and push and the deployment of cloud run so far. And another and it's ready. So we got that our cloud run service is ready, and now it's continuing. So basically, if I refresh now, it should our cloud run service should show up. There it is. And now it's just getting the data because it was not provisioned with Terraform. I'm pulling all of this data, which I will actually use here as outputs to show what the randomly generated URL is and so on. And while that's happening, and what it's doing now and what we're waiting for, which can take a while actually, is that it's creating the custom domain. And by the way, all of the now is part of the Terraform TFR, so I'm actually setting it to use for this domain name. And so this can take a while. In my experience, it can take from 5 to 15 minutes. It really depends. So I'm not sure what's happening on the Google side, but that's how it is. So while this is happening, I can also show you, for example, manually that everything has been created. So we have our URL, randomly generated one, and there's our app. It's running. It's all good as it should be. And I will now just wait for this to complete, and then I will continue the video. So the custom domain has finished. It actually took it 14 minutes, 40 seconds. And now we have our data information. So our cloud service is ready. Service URL is not there for some reason, but like you might just need to rerun Terraform apply, and then it will show up. Let's see if this is actually the case. Yep. So there's our app. So if we go, if we go here, we also see that it's here. The Cloud Run is here. And let's go. Let's verify it one last time. Yep. So there's our app. It's all working. So, actually, like the last step, what it was doing, and to get to the whole failover situation. So, idea is that this workload can just keep running like this for months. It's not gonna incur any costs. And now that we have the domain ready, so let's say my cluster goes down or something like that. The domain name is already there. It's going to be in this waiting for certificate provisioning state. You must configure your DNS. So let's say my cluster went down. Let's change the DNS. So this is where I'm going to do the live migration. So how to do this? I go to the custom domains. I go to DNS records, and I literally copy one of these. So in another window, I will actually update my DNS. I'm going to show everything that I'm doing on the screen. You don't need to see all of the my DNS records, and I just updated it. And let's see, we can also verify. So if I do watch dig atuf.fullcontrol.org, and that's for atuf, and watch dig atuf.app. So you can see that there's the old record, which was just a CNAME pointing to my reverse proxy, and same with atuf. So it's gonna take 39 seconds until it refreshes. So we're gonna give it some time for it to do this. I'll pause the video and we have 5 because 3, 2, 1, because what happened here is, and now it's on Google DNS, and I'll actually start the timer just because see, last time it took 9 minutes for how long it's gonna take. So what I did here is I lowered TTL on my DNS for DNS records for these two domains to only 1 minute. So that it changes to the new record in a minute. And then an ideal world, how this works is that you have the new workload ready elsewhere, and you would just do a DNS change, and now within a minute I would be running on a new, maybe new cluster or a new region or new data center or whatever. So, and I'm getting alerts that full control is down now. But this, for example, would allow me on the phone. I could easily update my DNS records and off I go, right? So how this works now is that this step, it depends. I had it from like 5 to 10 minutes. So what we're doing now is we're waiting for this check mark to turn green, and then the domain mapping will be in active state. And after that, it will take additional time for the changes to be picked up and ready. And if we go to atuf.app, yeah, it's redirecting and it's not reachable. Just I want to share this in case you're doing this on your own and you're freaking out because you don't know what's happening, because it's not very verbose. So I'll just give it some time now to see when the changes are propagated, and I'll leave the timer just so you get a feel for how long this really takes. But actually, while I'm waiting for this, I want to do one last step, which is also mentioned here as part of the imports. Yeah, since the Cloud Run was deployed with cloudbuild.yaml, so if I do Terraform destroy, everything will be destroyed except Cloud Run service, which I would then need to go then manually destroy it. So that's why I have this file here, and it has instructions what to do here. But basically, I need to copy this line because as part of the imports line here, the last part, I just need to update this ID with the project to replace project and location. And since it's this, I'll just add that, unblock this whole block, and now I will run Terraform plan generate for it to show me what happened here. For it to show me what it would plan to do and create a new file out of this. So let's see how it goes. So what it did now, it actually fetched all of the data of my Cloud Run service, which region, what is the name, which project, service account it's using. It's all here. The memory, CPU that it's using. So it made a plan out of this in literally this file. So what I need to do now, I just review this file. I can do a plan, but I already saw what's going to happen. So what I just need to do now is run Terraform apply again to actually import this generated resource, and then it's going to be managed by Terraform. So let's copy this, and I'll just paste it. And now it's literally applying the changes. And now also the Cloud Run, which was deployed outside of Terraform with cloudbuild.yaml, will also be under Terraform's management. So I can even check this. For example, if I do Terraform state list, because it's all part of the state file. And this will be the... No, not Cloud Run. I believe, yeah, this is the one that it just imported. I should have ran it before to see the exact comparison. So that's how you also do the import. So let's go back to our Cloud Run. Okay, so it's green state. That's great. I'll actually check. So it actually happened under 5 minutes. So now the domain mapping is active. So now it's running. It's all set up. But there are still some changes which are happening. So this is why I show this because when I saw it for the first time, I was like, wait, it's set up, it's active, but I'm still not seeing anything. And yeah, again, getting back to it, it's not ideal because in ideal DNS switch, it would happen in a minute and your workloads are up and available. But I still think this is better, the 10 minutes or whatever it ends up being, than having an outage that lasts for hours, for example. So now let's give it a bit more time. I'll refresh from time to time to see if it's ready or not. I'll pause the video. And I'm literally getting an alert that the site is back up. So that took 7 minutes and less than, well, let's say 7 minutes to finish. And atuf, it's available. So it's on atuf.app. I get redirected. Yeah, I can verify that I'm really running on Google by certificate, and I can see Google Trust Services. So yeah, that's how to. And that was the last step as part of this guide. So yeah, happy hacking, and if you find this useful, please consider becoming my sponsor on GitHub. And that's about it. Thanks.